Hello everybody, so today I am going to discuss aromaticity conditions. So before that, do subscribe my channel. So we are going to discussing aromatic conditions. So these are basic things, so means that it is बहुत मज़ा आएगा. This topic is so aromaticity conditions. What are the conditions have aromaticity? So how to find out aromatic and non-aromatic here? So aromatic and non-aromatic and anti-aromatic. How we can find these three names, right? So in aromaticity, so what are the conditions and what are the rules? Today we are seeing with examples. So I will be completed with short time. So this is the most important topic before we are going to learn organic chemistry, right? So it is a very important thing, aromaticity. So this topic will be बहुत मज़ा आएगा. So soon as possible. So for example here, benzene. So now we'll see the characteristics of benzene here. So benzene, so before that it was given by Kekule, and before that two scientists are proposed, Robinson and Thomson, J.J. Thomson. They not accept Kekule rule. So here 4n plus 2 rule, 4n plus 2 rule, 4n plus 2 pi electrons. So this is a Huckel rule. So I am not going to discussing Huckel rule, but today I am going to how to find out aromaticity and anti-aromaticity and non-aromatic compounds when we draw the structures with example. So how to find out aromatic and non-aromatic compounds. Okay, so I am not going to discussing Huckel rule. So because I will give you best clue to find out aromaticity conditions. So now we'll see the conditions of aromaticity here. So first one is the compounds which is the compound should be had planar, and it has conjugation or alternating double bond, and it should be cyclic. So it should be cyclic and conjugation and with alternating double bond. Alternating double bond here. So this is the basic conditions, and 4n plus 2 rule. It involves 4n plus 2 rule, Huckel rule. So this is the conditions of aromaticity. Okay, now we see examples. So we write examples. First one is benzene. Okay, benzene. Next naphthalene, or next one is we see anthracene. Here these are structures of tricyclic compounds or monocyclic compounds or bicyclic compounds. Okay, so how we can find out so these are more examples of aromaticity. So we are seeing conditions of aromaticity. If it is odd number is there, so 3, like, and if it is even number is there 2. So here when we find out the pi electrons in the conjugation, so we easily find out which is aromaticity, which is anti-aromatic, which is non-aromatic. So here first of all, for example, benzene thing we see here 6 carbon group is there. Okay, 6 carbon atom and 6 with 6 hydrogens, means 12 hydrogens. Okay, so here how many pi bonds are there? Here 1, here 1, here 1. So 3 pi bonds are there. 3 into 6, 3 into 2. So 6 electrons are present in benzene ring. So here only 3 pi bonds are there. So if it is 3, odd number is there, so it should be aromatic. So this is the aromatic compound benzene. So it is a more stable compound. Okay, next one is naphthalene here. So here 1, here 1, here 1. So 5, 6, 7. If it is 7 is there, should be and means aromatic compound. So these are the aromatic compounds. Anthracene also. Here also 7. Okay, here also 5. So these are the all aromatic compounds because they give odd numbers. So when we follow Huckel rules, also it should be give easily to find out the aromaticity. So but here I am going to give you a small clue about the odd number. So which is odd number from the structures, and even number, those are the compounds are so aromatic and anti-aromatic. Okay, so now we'll see another example is, so here we see with now more example here. So here pentadiene and cyclopentadiene, and here another example is, here also same cyclopentadiene. So this is a different species, okay. And this is another example, so decalin. So decalin here also, here different form. So when here also another example we see, which are cyclic compounds, okay. So hetero means heterocyclic compounds, or so monocyclic or dicyclic or polycyclic compounds we are seeing. So here now we'll see, now you find out which is aromatic, which is anti-aromatic, which is non-aromatic. So if they are not showing odd number and even number, they must be so non-aromatic, okay. So now we find out, so this is a cyclopentadiene because here 5 carbons are there. So here 1 2 3 4 5, here 5, so 5 carbons is there. So penta, here cyclic form, so alternate means bond is there, 2 bonds, 2 pi bonds is there. So cyclopentadiene, structure name is cyclopentadiene. So now find out, so it is aromatic or non-aromatic. So here 2 pi bonds are there. So if it is 2, it's an even number, so it should be anti-aromatic, okay, anti-aromatic. So anti-aromatic here more stable, means unstable than the aromatic compounds. Anti-aromatic compounds also their same characters. So here another example is, so here is a negative charge also involving conjugation, alternative double bond, cyclopentadiene or triene. So here 3 bonds is there, so it is a even odd number, it should be aromatic. Here another example is there is 2 bonds, so even number, aromatic. So positive charge which cannot involve. So here decalin, so 10 carbons is there. So here there is no pi bonds, so that's why we cannot find out this structure. So this is a non-aromatic, so no pi electrons, non-aromatic. And next one is, it is also non-aromatic because no pi electrons. So here we can't find out this one. So this is important things to know, aromatic conditions, and we can easily find out which is aromatic, which is anti-aromatic, whatever the compound they given, okay. So these are basic things, guys. So to find out, so conditions of aromaticity, okay. So again मैं बता रहा हूँ what are the conditions of aromaticity. So aroma means, so it is which give pleasant smell, means aromaticity. So these are involved means conjugation process, delocalization takes place within the benzene ring. So with whatever the compounds they are given, okay. So this is a planar, the compound should has planar and cyclic form and conjugation and 4n+2 rule. So this is the aromatic conditions. So I will be completed here in short minutes. So finally do subscribe my channel and watch this complete video for understanding well. Thank you, guys.